Our job is to factor out the trinomial 12x squared plus 17x plus 6, and as you can see in this trinomial the leading coefficient is 12, which is different from 1. I want to show you the method for this, which you have probably not learned in school, and this method works for all trinomials where the leading coefficient is not 1. Well, the first step of this method is to take the leading coefficient 12 in this case and multiply it by the free member, which is 6. The trinomial then gets transformed into x squared plus 17x plus 72. 12 multiplied by 6 is 72. The second step is to factor the new trinomial we have. That means that we have to write it in the form x plus something multiplied by x plus something else. In order to find these two unknown numbers, we have to determine which properties they have to satisfy. The first property which they have to satisfy is that they have to give a product of 72. The second property which they need to satisfy is that their sum needs to be 17. Let's call these two numbers alpha and beta. I am doing this just because I want to write in the clear terms what I am doing here. So we have that x plus alpha multiplied by x plus beta, and these numbers alpha and beta have the two properties which we have talked about. The product of alpha and beta must be 72, and the sum of alpha and beta has to be 17. What we now need is a list of numbers which multiply to 72, and those numbers are 1 multiplied by 72. The second pair is 2 multiplied by 36, then we have 3 multiplied by 24, then we have 4 multiplied by 18, 6 multiplied by 12, and 8 multiplied by 9. Now from all these numbers in our list, which two add up to 17? The answer to that is 8 and 9. So that is why I am going to take that alpha is equal to 8 and beta is equal to 9. And when we plug them into their corresponding positions, we get x plus 8 multiplied by x plus 9. The final step is to figure out what has happened with that number 12, which we have multiplied with. That number 12 went into our numbers 8 and 9. So now we have to divide by 12 to cancel out that effect, that multiplication which we have performed previously. So we have x plus 8 divided by 12 multiplied by x plus 9 divided by 12. By reducing the fraction, we get x plus 2 over 3 multiplied by x plus 3 over 4. The only thing that is left to do now is to take the denominator, 3 in the first case, and multiply that by x. So we get that 3x plus 2 is the first bracket. And we are going to do the same thing with the second bracket. We are going to take the denominator 4 and multiply x with it. So we get 4x plus 3. If you want to check the correctness of the solution, you can expand the brackets. So 3x plus 2 multiplied by 4x plus 3 is equal to. By multiplying each number of the first bracket by every number of the second bracket, we get that 3x multiplied by 4x is 12x squared, plus 3x multiplied by 3 is 9x, plus 2 multiplied by 4x is 8x, and 2 multiplied by 3 is 6. And that is equal to 12x squared plus 17x plus 6. And this is the trinomial which we have started from. So for factoring the original expression, this is our final solution. 3x plus 2 multiplied by 4x plus 3. Let's try one more example. 6x squared minus 5x minus 4, just for exercise. We're going to apply the same method here. We're going to follow the same path which was followed in the first example. So we are going to take the leading coefficient number 6 and we are going to multiply it with the free member, which is negative 4 in this case. That way we get x squared minus 5x, and 6 multiplied by negative 4 is negative 24. Now we are going to write this trinomial in the form of x plus something multiplied by x minus something. Note here that because we have negative 24 in this position, in the free member, we are going to have this minus sign over here. So whenever you encounter a situation like this, when free member is negative, you are going to have one plus and one minus sign here. So we are now looking for the two numbers which are going to multiply to 24. The first pair of these numbers is 1 multiplied by 24. Again, we are forming the list. So the second pair is 2 multiplied by 12, the third pair is 3 multiplied by 8, and finally we have 4 multiplied by 6. Remember that in the last example we were looking for that pair of numbers where the sum is going to give us the coefficient which stands next to x here. In this case we are not going to do that, because we have opposite signs here in these brackets. We have plus and we have minus. We want to find two numbers, alpha and beta, we called them in the previous case, and in this case, those numbers are going to satisfy the two properties. When we subtract them, we need to get 5, and their product has to be equal to 24. So the pair of numbers in this list, which gives us all the products of 24, we are looking for that one pair which is going to get us number 5 when we take those two numbers and we subtract them. Well, that pair of numbers is 3 and 8. 8 minus 3 is equal to 5. So the last thing that we have to figure out is in which of these two positions does the number 8 go in. Since we have negative 5 at this position here, we want to pair the larger number with the minus sign. So 8 goes here because of the minus sign, and the remaining number 3 goes in the remaining position. So we have that x plus 3 is multiplied by x minus 8. Remember that number 6 which we have multiplied by. Now we are going to divide by 6 these two numbers 3 and 8. So we have x plus 3 over 6 multiplied by x minus 8 over 6. By reducing 3 over 6 and 8 over 6, we get 1/2 in the first case, and in the second case, we get negative 4 over 3. We are going to take the denominator of the fraction number 2 and multiply x with it. So we get in the first case 2x plus 1. Notice here that 1 stays. Only the number 2 is gone because we have paired it with the x. We are going to do the same thing in the second bracket. So we are going to take number 3 and multiply x with it, and we get 3x minus 4. And to check for any mistakes, you can multiply each number of the first bracket with every number from the second bracket and see if you get the trinomial which we have started from. In this case, that you will get, and this is our final solution. Thank you for watching. Please like, share and subscribe as your support means a lot to me. Please leave a comment. You know that I love reading those. and I'll see you in the next video.